Hello and welcome back to the channel. Today is the day of our next big step in our process. We are going to start writing codes for different models. But first, a small change. In previous steps, when I was creating a project structure by mistake, I wrote models for linear regression, neural network, and random forest as Python files. Instead, there should be folders where will be collected all the processed files for the linear regression, neural network, and random forest accordingly. I have updated the project in a Git repository, so feel free to get the data from repository which is up to date now. But you can wait before watching till the end of this video and then download it. I'll add the Git repository link to the description of this video in case you missed the one which it was including. So what we are going to do today, we are going to work on this file, train linear regression. What is linear regression first? This is a supervised learning algorithm which is used to predict a continuous target variable based on the one or more input variables or features. It's one of the simplest and most widely used models in statistics and machine learning. The core idea behind it is to find a linear relationship between the input variables or features and the target variables. So speaking not in definitions but on everyday language, it is like whenever we use linear regression, we are trying to predict something based on what already happened, kind of building a pattern of behavior, or based on the previous values try to find out the dependency between those values and a linear dependency, and based on it try to give what will be the next value. That's what it's called, why it's called a prediction model. So in a stock prediction context, linear regression assumed that the future stock price can be predicted as a linear function of past stock prices by fitting a line to the historical data. Imagine historical data as a graph and fitting a line into it. So by fitting that line, users are trying to capture underlying trend and make future prediction based on that trend. Why in particular use linear regression? It is useful for time series analysis when the goal is to predict future values based on the historical data. In the context of stock prices, this can construct a model of relationship between the previous day's stock prices and the prices for the next day. Sometimes it cannot capture complex market behaviors and patterns, such as like unexpected price change, or what it's called in stock market volatility. It can still provide a simple interpretable model that is effective for detecting longer term patterns, trends, or relationship. It is simple, it has great speed, it's great for a starting point for stock analysis. It requires less power compared to more complex models. But just to be sure and be on the same page, none of the prediction models works 100%. It's not like you got the universal instrument for predicting everything and you can make all your investment decisions based on that. That's never true, because none of these models are counting the stock price influence on a different market data, like different factors which affect the market data. So none of these models are 100% true in prediction. What we are trying to do, we are trying to find out how this model works, how it predicts, and what is the correlation between it and the real actual stock price. This much for introduction. Let's start our code with imports as usual. We will import numpy as np, we will import pandas as pd, import os, import sklearn linear model, import linear regression from sklearn preprocessing, import the one that we imported on our main Streamlit app, max scaler, and import job. We will use numpy for numerical operations and arrays, pandas for data manipulation and reading CSV file containing stock data, OS to provide access and path for the folders where we will keep the models and from where we will get the raw data files for stock prediction. Machine learning algorithm for linear regression, min-max scaler to scale the stock price between 0 and 1. This is a tool which helps the linear regression model work better, and joblib to save and load the trained model from or to disk. Let's define the base directory paths, or we can even open here and copy it. We will copy these files, but then we will make our modification based on our needs. So base directory is the same. We do not need to change anything in here. We need to introduce new variable. Data directory is less path join the base directory. It will be our data. As you saw during one of our videos, files are generated in data folder, so we will use the data folder and slash excuse me. Now model directory where our results will be kept is the same as path join base directory, then models folder, and then linear regression subfolder, and let's make tiers. So here exist okay equals to true. So this will create a model whenever, even if the directory exists, if it directory exists, it will not create model, but if it doesn't exist, it will create. So we are writing this to avoid conflicts whenever the folder already exists. Next, we are going to load the file for S&P 500 stocks. CSV file path equals s path join base directory SP 500 stocks CSV SP 500 stocks equal pandas read CSV and CSV file path. Next, we are going to train our linear regression model. Let's define a method to do that. Let's give some space to separate this logic. Dev train linear regression for symbol. Now we are going to load the data. Data path equals s path join data directory and string symbol CSV. Now this line of code will get the file based on the symbol name from the data. You remember that in data folder, once we run our get data code, it will save CSV files with the stock symbol as a name of the file and CSV as an extension. So here we are grabbing those files in a date directory. Date directory. My bad. That's correct. After this, we are checking if that file exists, because sometimes might be that we are not able to get the data. If not, s path exists, data path, then print string data for symbol data file for symbol does not exist, and simple return. Nothing to return here. Now, stock data will be equal to pandas read CSV data path. If stock data if the following print valid data for symbol and again, return nothing. Now stock data, we are accessing now stock data and the date field of the stock data. Date equals pandas to date time, stock data, date, and stock data dataset equals index for date in place Let's check if the stock data is null or no values on it. If stock data close is null, print no close price for symbol. So we are checking if there is at all any price information or close price for the particular symbol. Return time to use scalar. Scalar is min-max scalar as data is received. Feature range equals from 0 to 1. Try scaled data equal to scalar fit transform stock data close field values reshape within the range from -1 to 1. Accept value error as A and print error scaling data and A, and again empty return. Now here with min-max scalar we use this to scale the stock closing price to a range within 0 to 1. This helps the model perform better. Stock closing price is reshaped into a 2D array. You remember that neural network was the one that required 3D array, and for linear regression and later for the random forest, this will be only 2D array. And next it is scaled, and if the scaling failed, we are throwing an exception. Now after this, we are creating our dataset. Def create dataset data back equals to 100. Basically, it's pretty similar to what we did in main Streamlit app. X, Y. Let's copy actually that part from the Streamlit application. Copying and pasting it here. Adding tabulation to avoid error display. Again, this helper function prepares the dataset for training by creating a sliding window of stock prices with the duration of 100 consecutive days of stock price. We provide X as an input, which is containing the data for 100 days, and getting Y as an output. It is for 101st day. Basically, Y is our prediction. Now, when it's time for train the model, we are providing a set of data. Look back equals to 100, X train, Y train, create dataset for scale data, and if when length of the X train is equal 0, or length of the Y train equals 0. So if we don't have anything to train our model on it, print not enough data train model, and again empty return. Now, with dataset creation from Streamlit app, let's fine-tune it to the needs of the linear regression model. With creating an empty lists for X and Y, let's update the code here, and instead of updating only Y, we start with updating X for the beginning. I'm sorry for this going back and forth, but again, I'm a beginner and I'm trying to do it quick, to not make video too long, but sometimes I'm doing mistakes, so I'm learning not to do them together with you. Append data for I plus look back and to 0 and y will be append to back and 0. Now with this part of code we provided x, we are appending the previous 100 days as our input data x and 101st day as the prediction, so the next day of our data set. X train and Y and Y train is complete, and now building and training the model. Model equals to linear regression model fit X train Y train. Here we initialize the linear regression model and trains linear regression model on the X train and Y train data, which we defined here. Next is going to be to save the model result. Model path equals to OS path join model directory and f string with symbol and the extension for linear regression, which is lr.pkl. And now job lib dump model path. So this job lib is going to save all the trained model to the location which is mentioned in a model path. This allows model to be reloaded after each file is completed. So here goes the dump. Now let's apply all the model work to the list of stocks from SP500 list. For symbol in SP500 stocks, symbol field, train linear regression based on the symbol. Again, the global idea, we are getting the stock data from the CSV file, data is validated, and if valid, it is scaled between 0 and 1 in our with our min-max attribute. A sliding window of stock prices is created to generate the training dataset. A linear regression model is trained to predict future stock price based on the past 100 days, and the trained model is saved on the disk in a provided location for future use by Streamlit application. Let's see where we went wrong. We have one error displayed on above. Necessary double parentheses just made it worse. Okay, our model is ready, explanation is given, and next time we are going to work on the random forest. Now with this ready, let's push the code to the Git repository, git add all, git commit -m updated linear regression model code. For your own benefit, try to be very precise in your commit messages, that this will help you on the first place to identify if something goes wrong, what you committed, what you did that might cause the issues with the code. And git push origin master. Code is pushed, you can see the Git repository, and I'll make sure to add this to our video description. This will be all for today. Thank you very much for staying with me. Next time, as announced, it will be train random forest file, and we are going to write the code for random forest. Thank you. See you next time. Bye bye.